Good evening, everyone. I'm Ram Balaji. I'm your host for today's class. Okay, sorry for the inconvenience caused yesterday due to the few technical issues. We have solved all of them. And so let me tell you what we are going to do today. Okay, we are going to create something like this: a piston and a cylinder. I'll teach you everything what I was trying to tell yesterday from the beginning. So you need not worry, just sit back and listen to what I'm saying. You will be able to create something like this, and also you will be able to like animate these kind of things. Okay. Am I audible to you? Is it clear? Please let me know. Uh, yes. Okay. Let's start. Then. Okay. This is how actually the Fusion 360 window looks. Okay, yesterday you were not able to see few things up over here. This region is called as the browser region. Whatever sketches like bodies or components you are going to create will show up in this region over here. See, already we have created, and so all these components are visible in this particular region. This is called as the view cube. Using the view cube, you could change the orientation, like in the way in which you look. Okay, if I want the front view, just click on the front. This is the home button. This will give you a perspective view. Okay, and the bottom panel you could see like few things over here. This is orbit. If you click on this orbit and just hold your mouse, and if you move, you can just freely move this component or whatever is on the screen. This is other things are like other important things are like fit. If you want to perfectly fit your screen, this option can be used, and shortcut key is pressing double clicking you using your scroll button. Okay, again I will go back to the home position. Okay. um, so other things are like data panel. This is the data panel. This is how the data panel looks like, and we can always upload things and like folders from your computer and everything. If you want to save something, all these things are actually saved in the cloud. If you want to save it in your personal computer, just go to files, export. Okay, the export, you'll have the name and the type of file in which you want to save. Okay, the location also, you can choose your location wherever you want to save it. And one more thing is that if you're going to 3D print or do something like that, your design should be in different format. Like there are common, these are like few commonly used file formats: step file format and STL file format. STL will be used for 3D printing. Step is for like other, if you are using some other software apart from Autodesk Fusion 360, if you're going to use SolidWorks or Creo or something like that, you can normally save it in a step file and transfer these things. Okay, so let me start from the basics. Clean slate. Okay, if you click on this icon, eye icon, you can change whatever visibility. Right now I want to view our origins. Okay, so I'm going to create a sketch. I'll be creating in this right plane, and I'll change my view to right. Okay, once you click on the sketch, there will be a panel to your right side. Okay, on this you can change few things. I will tell what all you can do using this. Initially, let me start with the cylinder's body. By clicking create, you will be having different options like lines, rectangles, circles, arcs, polygon, everything. Okay, for a cylinder, we will be needing a circle with center point and its diameter. Click on this option, go and click on the origin. Try prefer using the origin as the reference for like symmetric. If you're going to create something with a symmetric shape, try to create it using the origin, because in later stages it will definitely help you. Okay, I want yeah, I want 80 mm to be the diameter. Just click enter. So yes, you have created a cylinder. So one more important thing is that in certain times, like if the without any including parameters, that is parameters are like variables. You can change, you can, instead of giving 80, I can give it as something like id1. Like if I place it over here, you could actually wait, man, yeah, you could see something black. Mm. Okay, see, D1 is equal to 80 mm. It is a default parameter which is being given by the Fusion 360 software. But you can create your own parameters. Just go into modify, change parameters, under user parameter. Just you need to click on the plus icon and you can use it. Right now, we have give cylinder ID. Okay, so cylinder like cylinder underscore ID. Okay, this will be 80 mm. Now create again. uh I will create cylinder length. Okay, cylinder underscore length CL. This will be 170 mm. Again, then wall thickness is 5 mm. Then these are the, like, you can create all the parameters whatever you want for the entire design in this, and say I'll be adding this to my favorite list by clicking on the star icon. Then I will close it. Now I'll just click on this, and instead of that, what I gave was, if you just press C, you will see C ID, that is your cylinder's inner diameter. Okay, I'll click on this and click enter. Okay, now it's fixed. You can see now it is like f of x is equal to the diameter, that is the 80 mm. Now I'll create another circle. Okay, from the center to somewhere, I'll just snap it. Now to change the, I want the wall thickness to be 5 mm because I already created the parameter over there. Just click on the sketch dimension, choose one circle, and next choose the another. Now you will be having the thickness between them. Just click on this one, and we gave thickness one as one of this parameter. Just click enter. Okay, now it's fixed to 5 mm. Now I will finish the sketch, come outside. Now what I'm going to do is, I'm going to rotate it. The shortcut key is, hold down your shift button and hold your scroll button and just move in whatever direction you want, so you could orbit around this component. Okay, I'll go to the home position again. Now I'll extrude this one. When I click on extrude, there will be a panel to your right side. Okay, using this panel you can change all the parameters. I will go into, I'll tell you what all these mean. Okay, profile is which part you want to extrude. Just select what all you want to extrude. I'll be selecting like both the circles right now, and where you want to start. Okay, in one direction if it needs to be like in a particular direction, or if you give as two directions, it will be in two different, you can control, like with the sketch as the reference, it will move in both the directions. Or if you wish it to be symmetric also, it can be symmetric. Right now I'll go into like one direction, and I will change also the distance to be extruded. Yeah, someone has asked a question. Diameter can be changed at rotating. Can you please like elaborate? I am not able to understand what you mean by rotating. Or like you could hold on at the end of the session. I will be trying to answer like all your questions. Okay. Initially, like if you want to change something's diameter, like I'll go back to the sketch. Okay. If you click on this timeline and just click on like, sorry, I'll cancel this one. And right now, see, you could, if you right click on this timeline, you will be able to see a pop-up. Okay, in this I'll give a edit sketch. If you want to redimension something, if by default, if you are able to see some dimensions, just double click on it so that you can change it. Or else if you assign, in some cases you won't be able to see what's the dimension. At that times you could use this option, sketch dimension. Just click on it and click on whatever object you want to like change the dimension. Okay, right now I'm clear, I guess. So I'll be back. Okay. uh in the extrude option, yeah, select both these profiles. The direction will be one, and we gave the cylinder diameter to be um yeah, c underscore length l. Okay, now actually this is coming in this particular direction. Okay, if I want to change it in another direction, either you could pull it back or just give a minus over here, minus c id. Okay, now we have created our cylinders like outer body. Now over here you could see the operation. Okay, it can be a new body or a new component. Like I will again tell what is a body and a component. Initially we will create this as a body. Okay, now by default your sketch will become invisible. Again, I want the sketch to be visible. I will hide the origin by clicking on this eye icon. So what I'm going to do is cut. Again, you for cutting also you will be going into extrude. Select the profile. I want to select the inner circle. Okay, if you click on it, it'll get selected in the same likewise in one direction. I will move it. So there are two options, like for like creating something like a shell, outer shell. You can either use this option. I'll go through both these options. Okay, we created the cylinder's length to be 170 so like I will give right now minus 165. So there will be a 5 thick wall at the back side of the cylinder. Okay, and over here you could see, but in the operation by default it is changing to cut. In some cases occasionally it happens, you will be not able, you will not be seeing cut, instead you will be seeing join or something. Like in that in those kind of times you can you can change it manually to cut. Okay, if I give a, if I select okay, it now it will be a hollow structure kind of thing. Okay, what if we don't want to use this extrude? Okay, I will be deleting this one from the timeline. Another option is in the modify. If you under modify, you can see something as called as shell. Okay, just click on this option and select the face you want to shell. Okay, now the thickness we have already mentioned thickness to be a parameter. Okay, 5 as the thickness. Now you could see the preview, okay, how it will be created. This is also one of the option to create something hollow. Predominantly we will be using cut because it gives more control over how we do stuff. Yes, now right now we have created our cylinder. Okay, now you could see this cylinder. If you click on this cylinder, it will like highlight which portion it is in the browser section. Okay, now you could see it's under the bodies folder, this particular body. Okay, if you want to convert into a component, the basic difference is that each component is made up of multiple body, one or more bodies actually. It can be, each component can be a single body or it can be like more than one body. And one more thing is that bodies cannot be moved because a body, each body will be having its origin as this top level origin. Okay, I will convert this body into a component. We need to just right click on this option and you will be seeing create a component from bodies. Just click on it and right now you will see component 1:1. That is the first instance. Okay, I will hide this one. Right now after creating a component, I'll be able to move this. The sketch is still visible, so I will hide the sketch also. So a component can be moved freely in this workspace because a component will have its own origin. See, because initially when you create a body, it was having the top level origin as its origin. Okay, once you convert it into a component, it will have its own origin. Okay, I will hide this origin for now. Okay, so it will be easy to move. Only using components, you can assemble. You can't assemble bodies. Okay, yeah, you can also see this particular component has its own body. Like few bodies can join together and also create a component. Yes, okay, I will close this one. So yes, the cylinder part is ready. I will hide this one and I will create a piston head. I'll go to the home position, and again, um, let me use this particular plane here because we used it already for sketching. Yeah, someone has asked how to rotate the structure with mouse. Okay, just hold down your shift button in the keyboard and press your scroll button. Press your scroll button, don't just leave it, just keep pressing it, and then you once you press it, you will be able to see this orbit kind of, your cursor will turn into an orbit kind of symbol. Okay, so once that happens, you can hold down your scroll button and move. Once you release it, this option will go. I hope you understand. Okay, I will come back to this home position again, and I will again do a sketch. Now it's asking me to capture the position because we move this component, right? We have moved this from this original origin to some other position. It will ask me to capture the position. No, I don't want to capture. I will revert back to the original position wherever it was originally created, and just I will hide it. Okay, now again I will select this one, select this plane, and I will select the create sketch. Now my previous sketch is also visible. What I am going to do is again create a circle for my piston head. Okay, just just enter this one, and yeah, now see, still I'm, my cursor is under like in the circle section. To move out of this, like to escape from it, just click on the escape button. Okay, now you will be able to edit your dimension. Double click on this dimension, and you will have like what we actually created was cylinders inner cylinders id, right? So cylinders id minus, I want a clearance of let's say 2 mm between them. So if I click enter, yes, okay, now this actually our cylinders id was 80 mm. I subtracted 2 mm from it, so we got 78 mm as a piston's head. Now I will just click finish sketch, and my sketch is not visible because it's hidden over here. Just click on this icon, and again I will extrude this one. Click on this profile and just change it to your like a suitable orientation. And for cylinders, like sorry, the pistons head, I am going to give let's say 50 mm, 50 mm in the other direction, so I'll put minus 50 mm. Okay, this is going to be either you can create it as a body right now or create it as a component. I'm going to create it this one right now as a component. Okay, I get component, and okay, now the pistons head is created. Again, let's this time we will use extrude cut to create a hollow section. Okay, so again, what can I do? I could have created a sketch earlier itself. So simply you can actually edit this previous sketch. Click on this, right click on the sketch, like second sketch which you created, and click edit sketch. Okay, I will create another circle. This time that was 78 right? So like either you could just snap here somewhere and change redimension it like this also. We have given thickness as 5 mm. So yeah, thickness, yes, right now it is 5 mm. Yeah, I'll finish the sketch, and I will again use extrude to cut this one. It is asking me to select this profile. I'll select the inner profile, change this orientation a little bit, and I will move this inner. This was the piston's head was like 55, sorry, 50 mm. Uh, Total depth was 50 mm. So I'll go with 45. It should be minus 45, right? For the other direction. Now it's by default, we have seen it is cutting because we are going in the, like, because there's already a solid body present over there. The only thing we can do is cut. Okay, the piston's head right now is cut. Actually, if you have seen in pistons, you will be having a ring kind of thing for putting gaskets, like, because if you want to compress something, it shouldn't escape using the clearance, right? For those gaskets, you will be having some groove cut on this piston. So what we will do is, I want to create a sketch. Okay, so I will, this time I will be creating a sketch in the bottom plane. Just click on this plane, create sketch. Now you'll be having this under the, you'll be prompted to sketch. Okay, now go to sketch. I want to create it exactly at this surface. So how can I do it? There's a option called something as project. Yeah, you can project and include, right? If you click, go to create, project include, project intersect. What it means is, if I give project intersect, we have already selected the top plane. Okay, if I select some geometry, for example, the outer surface, I'm selecting the outer surface. Wherever the outer surface cuts this particular plane, which we are sketching on, uh, will be we will have some marks. If you give OK, and I will hide this component. Okay, now you could see a purple line, right? That is the region where your cylinder's outer surface cuts the bottom plane. I will use this as a reference to create that groove. I will hide this component. Okay, for convenience, I'll go to the top plane, and what groove will be? This groove will be, let's say at this time, why not a square or a rectangle? I will zoom into, just normally scroll, and you will be able to zoom in and zoom out, or also you can use this option over here for zooming in. Okay, escape. I actually, okay. Now see, there are different types of rectangles. So here you could see 2-point rectangle, 3-point rectangle, and center point rectangle. I'll be using center point rectangle. Okay, it snaps in, and this will be like, we have created this one. And if you want, now right now you can see over here there are no dimensions. Like for certain objects you will won't be having dimensions, so in that case you can just click on, like, sketch dimensions, and click whatever side you want to redimension. Just clicking on it and just moving your mouse, you will be able to see what is the dimension. I want this to be 2 mm. Okay, now this side is changed to 2 mm. I want this to be a square section, for which you can use certain constraints. Constraints are something like with reference to something. You're normally, what is meaning of a constraint? You're constraining it to be in a certain way. Okay, if I want this line and this line to be equal, you will be having an equal constraint. Just click on this equal constraint and select both the lines. Right now you will see another different symbol kind of thing appearing on the screen. This is the equal constraint. Now it's a perfect square. Once like, to escape, again I'm hitting escape, and if you want to redimension it, for example I'm changing to 1 mm, you could see both these dimensions are getting changed because now they are equally constrained. I'll change this back to 2 mm, and this is how you use different constraints. There are, like, you can, by your, you will be able to understand most of these things on your own. What is parallel constraint? That is, if we click two lines, these two lines are parallel by default. Fusion 360 itself has applied this constraint. See over here, this is parallel to this one. You, if you just move your cursor over here, you could see a slight color change. Okay, that is the parallel constraint by default. Fusion 360 has applied. And one more thing, if you want to use, like, let me say, like I snapped it somewhere ran in random position, right? If I want to use some kind of reference, that is, from this point it should be at a particular distance, what I could do is I can create a construction line. Construction lines are something that are not actually a part of a actual sketch, but they can be used as reference. Okay, I'm using this construction line. I'm just moving this pen without holding the shift key button. If you just hold down your scroll button, you could move this pen. Okay, I'll be creating a vertical line. Sorry, my bad. If you put Control Z, it will disappear. Again, I will create a proper straight line. Okay, now I created a straight line. Just hit escape to close this, finish this operation. Right now, again, what I will do is sketch dimension. From this particular line, this should be say at yeah, 5 mm. Okay, so I will click on this one, click 5, and okay, now see, instead of this one, this has moved, so I will undo what I did. Now for like, now see, this line is free to move. What you can do is put fixed constraint on this particular line. I'm putting a fixed constraint, so right now this cannot move. Now I'm changing this to 5. Now you see this line is fixed over here, but this square has moved to 5 mm. Like this, you can use your constraints for like your convenience to create a proper sketch. And one more thing is that you could see that all these lines are now right now in black in color, because all these lines up like all the sketch is being properly constrained. If your sketch is not constrained, it will be blue in color. Okay, this is not actually, this constraint part is not constraining this color change. The black and blue is not a big issue, but for like an advanced level, this can create a certain, if you're creating something really complicated, you need to be your sketch to be like constrained fully. Okay, I will finish this one, and I will, okay, just double clicking my scroll button to fit on the screen. I will go back to my home position. Now you could see this. Now what we are going to do is revolve. Okay, revolve is something like if you create just see over here, we have created a shape in this region here. In this example, if you just place it over here, place it on this icon, you will be able to see what is the description. You're revolving a certain shape with respect to an axis. Let's revolve and cut a groove using this. I'm going to select, like, again, I'm going to double click and fit to the screen. The profile to be selected is this one. Okay, and the axis, next to the, we have selected the entire profile. Now it's asking for the axis. The axis will be the x-axis red line over here. Click on this axis and choose whatever axis you want. Now by default, the operation similarly similar to Extrude, you will be able to see the operation, it has cut or join, or we want to cut actually. Okay, this cut can also be a particular angle or a full or up to a certain entity. If you give up to, you need to select till this particular face. Actually we want to have a, if you give also angle, right now it's 360. If it's like 180, only half the groove will be cut. So or else if we need a full groove, so I'm selecting full, and I'm clicking on the OK option. Right now you could see a groove is being cut on the piston's head. So we have created the piston, and now the piston needs to be connected with the connecting rod and other things. Let me start sketching the connecting rod. Okay, I want my connecting rod to lie on this front plane. So I will hide my previous old sketches and select this plane and select create sketch. For convenience, I will move it to the front. So Connecting dot will look something like this. I'll create you. I'll actually go. Let me create a circle first. The circle, let it be some 20 mm circle, and another circle we are gonna create. Okay, another circle over here, same 20 mm, and I'm going right now. The distance between these two are not like we haven't any particular dimension, right? Click on to sketch dimensions and click both the centers. You will be able to dimension it. I want this to be 100 mm. Like 100 mm is a little bit. I'll change it to 150 mm. Okay, I'll move the pane so that you could see everything. And now this constraint is applied. Now I want to connect these two circles. Just I'm using the line option. Snap some point on the circle and click over here. Yes, you got one line. And for the second line, just click over here and click. Yeah, one more thing also I'll try to explain over here. Keeping this aside, we are going to create two lines. Okay, these are the lines. If you want to like change the angle, actually these two are right now perpendicular. This constraint is displayed, right? You could just right click on it and delete that constraint. If you want to change the dimension between these two, go to sketch dimensions. First click on this particular line, you will be able to change this dimension, and next click on this line again. Now you will be able to see the angle between them. If you want to change it to some 30 degree, now see, because there is a constraint over here, there's no constraint on this line, so this line is moving to accommodate for the 30 degree change in angle. Okay, I wanted to show you this one, so I will undo whatever I did. Okay, and get back to the original sketch. Okay, this is a sketch and we have completed. Now I'm again going to extrude this one. Okay, for selecting the profile, click on for the like all the portions which you want to extrude. Sorry. And now the thickness, let this be some, let's say 20 mm. Let's you get just rotate and see the view. Okay, 20 mm looks fine. Now what I'm going to do is I need a hollow, so like a through hole through this circular region. Okay, there are few options, like I'll come to the proper and actually zoom out a little bit. You can go to create, either you can extrude it. Extrude is the most like common thing, but we have already done extrude. For like exploring different options, I will use hole right here. Okay, select the face on which you want to it'll probably again it'll open a panel like this, and it'll ask you like whichever face you want to put a hole. Just I'm clicking on this. Excuse me. Yeah, okay, I'll be a little bit louder. Sorry. Yeah, okay, now you have selected the face on which you want to create your hole. By moving this one, you can either change whatever the whole dimension. You'll be given a small box. Oh yeah, you can, and I want yeah, 10 mm. Okay, and this center, it should be at the center. Okay, this looks good. And over here you could see hole types, like a simple hole or a counter bore or like countersink, something like this will be also visible. You can also have like taped, that is means you can have inner threads, like normally we put a screw or a nut in a particular thing, right? You can have threads like that, yeah, like while creating the hole also. So now we don't want any threads, we will be having a plain thing, and just click on Okay, now we have created a hole. um yes, now you could see again we want to create a hole over here. There are few options, like once you create a particular feature and if you want to do it more than once, okay, you could go into create pattern. There will be circular patterns and rectangular patterns. Patterns on path we mostly won't under basic level we won't be using them. uh, Only we will be using them like in specific regions. Like, for this particular one I'll be using rectangular pattern. Okay, use the rectangular pattern. Right now in the patterns, rectangular patterns option, you will be able to see pattern type. This is a face. If you click on this, you will be having different options like face, bodies, feature, components. Actually, this is if you want to like copy a component or a body, you could use whatever like either it can be component or body. Select this one. But this circle, this hole is a feature. It is a part of this component. We are giving some feature to it, like so. Select this feature, and next in the options, which feature you want to replicate, like pattern, create a pattern, just click on this and it'll get selected. The next and over here also you could see the quantity. It will by default it will show you three. Actually we don't want three, we want two, right? Like one one is over here already and we want to create another pattern. Okay, the extend type, this one is like extend, like what to say, between certain limit it will create like the number of features whatever you create. For example, if I say my extend to be 100 and create like 100 features, there will be one feature in each under like each for each million one millimeter there will be each feature. It is something like that. Spacing is that the distance between two features. For right now we will use spacing. Okay, and the spacing between them would be uh, we have created mm, 140, let me say 140. Select direction. Yeah, one more thing, it will ask you to select the direction in which um, you want to create this pattern. uh, I'll go with the X. Okay, I'll come to home position. Now you could see like the direction. Actually again it's changing back to three features. Actually we don't want three features, we want only two features. And again I'm increasing it slowly. I'll use my friend. Okay, now this looks something okay. Yes, now a circle is like the same feature is being patterned. Okay, similarly you can use where is this pattern? Yeah, pattern, circular pattern. Again for circular pattern you need to again choose whatever it is, a body or a feature, and then select this particular feature option, whatever feature you want to pattern. And one more the different thing is that like around which axis you want to create a like a pattern. You can use the X, Y and Z normal axis, or what you can do is like go to create a sketch, and we have already created a construction line to remember. We could create some construction line like at any region whatever wherever we want, and use that construction line to be also axis. That you can explore on your own, I guess. If you have any doubts like while trying, I will help you. I'll leave down my contact in the description so you can ask me any doubts. And another useful option is that mirror. If you want to mirror something, let me, okay, I before mirror, I think I will this. Yeah, see, we have created this connecting rod as a body. I will convert this to a component again. Okay, once I created a component, I will capture this position. Now I want to like create another copy of it. What I can do is use mirror. Okay, if you click on go to create like mirror, and this panel will be in front of you. Okay, now again create, this is a component, right? We want to mirror a component. Okay, to mirror a component, just click on this component option, and whatever component you want to mirror, then select the mirror plane. Okay, mirror plane, I will use this plane to be my mirror plane. Okay, once I click on this plane, you will see a copy of this is being created. Yeah, now right now we have created a component. You can create a face, a body, or a feature to also to be mirrored. Okay, we won't be using this. I just want to show this option so you could use it. We won't be using mirror right now. Okay, so this option is went. Similarly, we can also create like all these parts. I won't be creating all this right now because I have created the most difficult parts. This is cylinder, piston head, and the connecting rod. Okay, yeah, I'll show you how to create fillets also. Right now, these thing you could see over here, this is a abrupt change. A circle is changing into a rectangle over here, this corner. So we normally these regions are called as stress concentration. There will be weak spots and other things. To change it, what you can do is you could create a fillet. A fillet is something like you can round this edge. Okay, go to modify, select fillet. Okay, oh yeah, and now just click on whatever edge you want to fillet. I'm here clicking on this edge, mm, this edge, and this one. Okay, now it will ask me to give the fillet radius. I'll give it as 1 mm. 1 mm seems to be a little less, 2 mm, so it is quite visible. Okay, now you could see the sharp edge over here, which was, wait, hold on a second, sorry. The sharp edge is now turned to a curvature. Like you can use this option to like round off your edges and other things. Fillet is something like that. So we have created all these parts. This particular part is a bearing. Okay, I will show you here. Bear. This is, I didn't create this one. I actually got it from imported it from some options. Okay, go to your sketch. Okay, by we are using this, right? Under insert, go to McMaster insert a McMaster car component. These are like prefabricated CAD designs which you could use from the internet. If you go to this, you will be able to see a lot of like basic components like screws, bolts, nuts, fasteners, like a lot of things. See, you could see bearings over here, power transmission, or also you just click on find whatever component you want to click. Just if you type it over here, you will be able to see what component is here. I actually imported this bearing from this. I'll click on bearings. Okay, there will be different types of bearings. You can filter all your options in this particular region, and just click on a particular bearing type. Also, if it's too small, just once again, uh, sorry, McMaster fan. uh, I couldn't resize it. Okay, I couldn't resize it. Actually, you could resize this one. You make it a little larger. Okay, you could go into like whatever option you want. Go into screws. uh, Select a particular screw. I'm just selecting it at random. Now just scroll down. You will be able to see like a different available screws. Once you click on this particular thing, you will be able to see product details. And like if you see beside the product details, you will be able to see a small green thing written CAD over here. Okay, if CAD is available, means you have a CAD design for that particular product. Just click on this product details. scroll down, you will be able to see this. Okay, yeah. Now under here you will be able to see like 3D solid, 3D solid works or different option. Actually what we want is a step format. Okay, select 3D step, and just if you click save, okay, now you could see the component will be present for you in your particular sketch. Okay, like using this option you can import like prefabricated, like certain things are common, you need not design for each and every component. Like prefabricated things can be you imported using this particular option. Go to insert McMaster car and select the option. There should be a CAD design available, and change it to 3D step and save it. And one more interesting thing is that now right now we are working under solid section. If you go to tools, actually you can see add-ins. There will be our options called add-ins. If you want to create something like a gear or something which is quite complicated, normally you won't be able to sketch each and every part, and you need to create. For that you can go to add-ins, scripts and add-ins, click on scripts and add-ins. Hold on a second. Yeah, now you will be able to see different kind of these are actually Python programs and C programs which are like written by some people. Like Autodesk has also written few programs, and like if you go actually Google like add-ins for Fusion 360, there will be many paid and also free components. Okay, so yeah, right now actually I want to create a spur gear. Just select the spur gear and click run. You will be having like a similar panel, like what are the parameters you need to include. Okay, if you are like quite familiar with gears and other things, you will be able to understand what are all these parameters. I'm not going to go deep into this. Just if you change these parameters and click OK. One second. Yeah, see now a gear is being created. You could change these parameters, and you could create them. Okay, this will be, we won't be using this option. I just want to show you like this facility is also available in Fusion 360. Right now what we are going to do is, I previously created all these components and everything is separate. What we need to do is create joints between them, so that we could create something like this animating model or like moving model. Let me start with, initially we will, what we can do is we can set this piston and cylinder. Okay, there are a few type, before going deep into it, there are a few different kinds of joints actually under here. Okay, you can see motion, like there are different joints. Actually this piston head and the cylinder are sliding, so the joint between them is sliding joint. Okay, and over here you could say, see this one is rotating, right? This particular joint, if you could zoom in, this particular shaft and this crank are rotating. The joint between them is a revolute joint. And if you could see, there are three parts: the connecting rod, the bearing, and then a pin kind of thing. Actually a bearing will be connected like it will something in mechanical terms it will be called as tight fit or interference fit. We will be pressing this together, and so that the bearing won't be able to move with respect to the pin, while as the connecting rod will be able to slide on the bearing. Okay, there will be a revolute joint between the bearing. So predominantly we will be using three joints, like your sliding joint, your revolute joint, and your rigid joint. Right now the between the piston's head and the cylinder, we will be having sliding joint. Okay, so for sliding joint, actually to create a joint, go under assemble, and you will be having two kinds of joints. One is simple joint and as built joint. Okay, I will explain what is the difference between these two right now. Before like creating the joint, what I will do is I will align these two parts together, which part wherever I want. Okay, go to modify, click align, and from component, this is my from component. Okay, now I'm going to actually select, you could see the inner edge, and if I click this inner edge, and you'll be able to see the center. Okay, I want to align this particular center to this cylinder's inner edge center. So now I have selected where the from option is from, and I want to align it to. Okay, so I'll move it a little bit so that you could see it clearly. Now I am clicking on selecting this particular inner edge of the cylinder. Okay, now if I click, yeah, now you could see this piston head has moved from there to this cylinder's inner edge. Now they are aligned. I want to capture this position. Okay, I'm clicking OK. Now if you see, actually we have only aligned. Aligning is not actually creating a joint. I can still move this around freely. Okay, I will revert back to the original position, like where I, because we captured the position, right? So we will be able to revert back it to the original position. Now it's aligned. Now go into assemble as built joint. When something is aligned properly with respect to the mating element, we can actually use as built joint. Now I'm going into as built joint. My type of joint is slider joint. Okay, I'm changing it to slider joint. Select the components. They are asking me to select the components. I will select this component and this component. Okay, and it is asking me to select the position, that is like how it should slide. Actually, if you could see, when I place it over this inner circle, there's a arrow mark, right? Like it, so it will point in this, it will be able to move in this particular direction. So I'm placing it over here and I'm selecting this position. Now you could see that this actually we want the piston head to move with respect to the cylinder, but it is happening in a different way. Okay, but that's not actually an issue. You could still, because the order of selection, because we first chose the outer cylinder and then the piston head, right? So order of selection will change this one, but this is not an issue right now. You can actually, if you actually fully construct it, this won't be affecting your design. Okay, now the cylinder and piston head are free to move. See, look, I'll be able to move this. And one more point to be noted is that my cylinder over here is grounded. Okay, grounding is, if I don't, if you could see a red pin over here. Red pin, the what the red pin means is that you can't, you will be not, you will not be able to move in this space. I'm grounding this one to the particular position in this space. Okay, I actually want this part to be grounded, so I will ground this one. Now you could see only the, we are unable to the move the entire cylinder and the piston. We are only able to move the piston's head. So this is done. Okay, for now I will hide the cylinder. Next, what we will be doing is that I'll move it. I want this pin to be fixed to this holes. Okay, this will be a rigid joint. For creating a rigid joint, like this time we will use, simply we will use a joint instead of using as built joint. It's asking us to capture the position. Yeah, I would like to capture the position, and you could see the position and motion. Two options will be visible to you. Go to motion, because previously we selected Revolute, so it is in Revolute. Actually, we want a rigid joint. Select this motion to be rigid. So like these two parts shouldn't move at all. They are like fixed with something, like we are fixing it with glue, so that these two parts don't move with respect to each other. Okay, now what I am going to do is select this particular, select, okay, this particular face. I'm selecting the center of this particular face. By default, if you select any face, by default it'll show go to the center. Okay, and second component is going to be this one. I select this inner cylinder kind of surface, it'll move to this one. Now you could see, yes, everything is aligned. Actually, if you're a little bit misaligned, you could use these three arrows and align it manually also. But try not using that one, because like there might be it won't be that accurate as like the software if it does by itself. So try to align the center with center and those kind of things. Don't more try to use it manually. Click on OK. Okay, this particular joint is created. Excuse me for a minute. Yeah, sorry, I had to take some water. So right now this is a rigid joint is created. So if I try to move this, the pin won't come out because it's like fixed to this piston head. Next, we will be creating a Revolute joint. Okay, I will just resize it. For this Revolute joint, what I need is, this time I want this bearing to be like revolving around this pin. So what I will do is go to assemble, join, capture this previous position, and over here go to motions. Now I want Revolute, right? Now again go to back to positions, and there are different kinds of alignment. Previously we used simple, that is the center of one face should be aligned with the center of another. Now what I want is that um, the this bearings center point, the plane which separates divides this bearing into two parts, two equal parts, should be aligned with this pin's center. Okay, it shouldn't be like either to the left side of the pin or the right side of the pin. I want exactly to be in the center. So for that option, instead of using simple mode, we will be using between two faces. Select the between two faces option and select your first face. This is the first face, and by rotating you could see the other face. Selecting, I will just, and now snap point. Just moving your cursor over this body, you will be able to see the snap point. Just select the snap point. Okay, for the second component, for the pin also I'll be using the same option. I'm selecting the first face, rotating it, selecting the other face. Now just I'll move this over here. Now you could see, just moving it over this particular component will reveal you the point you want. Now keeping it, it will this that will be that is a, you could see a slight yellow color, orange or yellow color plane in the middle, right? If I keep it over here, the center, both the centers won't be aligned, but still it will be in the middle. I want it in the center, so I'm moving to the center and clicking on the center. Right now you could see that the center is being aligned. So yes, the joint is perfect. And so this so right now this particular bearing will be able to revolve around this pin. Okay, I'll to clearly see, what I will do is I will try to align this connecting rod. You will be able to see it in a better way. I'll do this quickly without explaining. Go to joint. Okay, I will still capture the position. Motion, I want a rigid joint right now, so I will go to between two faces. Select this face, select this face, and the snap point is, okay, it is in the middle. This particular component is fine, so I'll go to this one. I'll select this face. Actually, okay, it is not properly aligned. I will move a little bit, so this is aligned right now. Okay, once I created, you could actually see now the bearing is actually the connecting rod is not connecting rod is firmly fixed to the bearing, and the bearing is revolving around the pin. Only because of that we are able to rotate this connecting rod. Okay, so like similarly, if you arrange like assemble all these parts, you will be able to create something like this. Okay. um I will show you like another important thing. Okay, before and over here, if you see, actually while creating the components itself, what we should have done is that we should have renamed them. Just by double clicking on this browser, you will be able to rename whatever option you are. Okay, like similarly, it's a good practice to name it so that you will be able to easily identify which component everything. And also for this creating the joints, also you can just double like if you open this joints folder by clicking on this icon, you'll be able to see each and every individual joint. By just placing the cursor over here, you will be able to see where the joint is present. That you could see on this, like if you just look into this piston, you could see the which joint we are referring to. So by double clicking on this, you will be able to rename them. Once you rename, yeah, I have already renamed and placed all these things over here. Once you rename such things, what you can do is for a particular joint, if you want, just right click on it and you will be able to see different options. Edit joint limits is one of the most commonly used option, because if you click on this edit joint limits, it will be restricting your motion. Like for example, if I set the minimum, okay, minimum to be actually this is corresponding with this crank. Okay. I could set this to be 0 degrees and the maximum to be a particular degree. Then rest portion is that it will once you move this, it will actually like spring back to its original portion. If you check on this particular option, it will come back to its original portion. You can also define what the original portion should be. Okay, right now we are not going to use this. Like all this kind of slide, let it be slider, apart from like a rigid group, all the other like let it be a revolute or a slider connect joint, whatever, it will have its own joint limit. Okay, again I will click on right click, and you will see lock. If you particularly lock this particular joint, it won't be acting like a revolute joint, it will be acting something like a rigid joint. There is no motion, relative motion between the two components. Okay, and if you click on animate joint, actually you could, if I zoom in, yeah, you could see, right, this is getting animated. The motor shaft is rotating with respect to thing. Mostly if you once you construct your entire thing, you won't animate your joint. Just to escape from this, click press your escape key button. Again, go to right click on this particular joint and I will give animate model. Once I give animate model, you could see that the entire model is being animated. Okay. um Again, if you click on escape, yes, we are done. Yeah, pretty much done. Yeah, this is the last thing I want to actually show you. One more thing is that how you will save your file. By just clicking on this save button over here, it'll ask me to save. Okay, if I click on the save and again I'll go to my data panel, you could see over here we have saved only once, so you will see version 1. So like let me do a small change and again save it. Okay, now hold on for a second. Sorry, this is in another folder, my bad. So go to, now see, this is getting updated. So you could have different versions. By saving number of times, you could see all the version from the beginning. I have saved this like around 9 times, so like there are 9 versions available for this particular design. All these versions, whatever shown on your data panel, is actually in the cloud. What if you want to download them? Just as I already told, go to file, export, and then you can simply download them. This is all for the day. We are closing this session. If you have any doubts, let me know in the live chat. I'll try to explain. Yeah, okay. All these, what is meant by NC Pro? If you have any doubts regarding this particular session, yes, you have people have replied. Uh, Anything else? Okay. Can Fusion 360 be used for 3D printing? Yes. Yeah. You could use Fusion 360 for 3D printing, or also you can simply create a STL file, and so you could. Okay. Yeah, I will answer your question one by one. Hold on for a second, please. Okay. Yeah. Um. So yeah. Yes, you can convert this into a 3D model, sorry, STL file, and you can 3D print using this particular software itself. Yes, definitely you can. Space. Good. 3D model is efficient for space research. This is kind of ambiguous. Space is research in the sense, if you want to design something, if you want to design a telescope for space research, you could definitely design a telescope using like this sort of particular software. And then like 3D printing is now like one of the most sort of prototyping methods. Like if you're simply able to create a design, you will be able to print it and then create your actual prototype. Yes, this is actually this is used for project purpose and also in industries. Like few companies are also using this industries right now. If you see under my, like I am using an educational license which is valid for 3 years for like startups and other things. If you go into Fusion 360, if you just Google download Fusion 360, it will take you to the Fusion 360 page where you can actually like see different versions. There are like student version and other two versions. One is for like higher end industries, so like more than 1,000 people or something, and other is for startups and other things. That are, you can purchase the software also, and for educational purposes you can use this educational license. Is animation and simulation same? No, bro. Animation is different from simulation. Okay, I'll show you. Actually, we are animating this particular thing. If you want to like analyze, I will show you some analysis. Cost. Um, Sorry. Actually, analysis is quite different from animating. Analysis means like you will be it's like, so actually simulation means analysis. Okay, let me click and make it clear. Simulation is that you will be able to see, if I apply so much load on this particular region, how much would this like deform, or how much stress would it create. Yeah, see, look, I have already performed some analysis over here. That is a simulation over here. By applying so much force, this particular component will deform in this particular shape. This is actually an exaggerated shape. If you see like how much it would deform, and if you see stress, this is the stress regions. Like the blue regions are with less stress, and the yellow and red, looking on the scale, yeah, you could see wherever it is red, it is like at the maximum stress level. This is called as actually simulation. Right over here in the top left corner, you could see something simulation, right? Now you are in the simulation workspace. If you're going to go back to design workspace, you can go back. Actually, what you will be doing is that you will be creating a design first, and if you want to check whether this particular design can withstand all this load and other things, you could go into simulation and you could work. Actually, the thing is that you could actually change, going back to our piston cylinder, by clicking on this whatever pin or whatever component you have, you could actually see physical material. Go into physical material, you'll be having different kind of materials like metal, plastics and other things. If you click on this metal, like whatever plastic, if you want, let me say plastic, abs is the commonly used 3D printing plastic. Okay, if I just drag and drop on it, is one option. Okay, this particular thing will be changing into that particular. Now see, the cylinder is made up of abs material. Now if you can go to analyze like simulation part and see how much, whether your 3D printed model will break or not. Yeah, okay, animation is a shortcut key for duplicating some components. Actually, duplicating components, you can use Control C. It is actually not preferred to use because you will be like not you won't be exactly able to copy few components. One option is that here in the modify you can see move slash copy, right? Click on this, and whatever I want to copy this component means, just select on this particular component. What I want to do is just move, create a copy, check this one, and just move this one, and now see they will be having two copies. Yeah, this is how you can create a copy and other things. Okay. uh, yeah, someone has requested a session for simulation. Yes, we will think about it. I will try my best to have a session on simulation. um okay, other and which is the best software for designing 3D model handles? Fusion 360, SolidWorks, or CATIA? Actually, my personal preference right now is Fusion 360. CATIA, like, so Fusion 360 is more user friendly. You could see like a project. I showed you project and other things, right? Those things won't be mostly available in SolidWorks and CATIA. Fusion for like a beginner's purpose, like Fusion 360 is the best software. But if you see like in industries and other places, they will be mostly using something like a SolidWorks or CATIA, because Fusion 360 is relatively a new software. That is the reason. Okay, can you please send the attendance? People are, yes, the attendance link has been sent. Bro, is the software used for electrical students? Uh, Electrical students means this is actually a designing software. If you see my friends who are doing final year projects, and they are from EC department, they are doing their final year projects. All of the like like they are definitely in some place or the other place, they are using this 3D printing as in their project. Okay, so learning something or software like this will definitely help you in some point. If you want to prototype, if you're creating all the electrical students for, so okay, you're going to create some circuitry or some a circuit board or something, and after which you definitely need to have a structure to enclose it, to case it, right? So for in those kind of places, definitely this software, you need not be an expert in this, but knowing the basics will help you to create a simple 3D model which you can use. Okay, people can fill in the attendance link and you can leave. Thank you, that's it for the session. Okay, let me. Someone has asked a doubt. Amal, um, doubt not clear. For joining the components, we should bring them in the same plane. It's actually there are two kinds of joining, which I previously mentioned. On like hold on, yeah. One is that see, go to assemble and join. You what you need to do is that once you select a particular component, you'll be able to see a circle kind of thing, right? Inverted smiley kind of face. Okay, a circle or a dull yellow color circle over here. This yellow color circle of one component will go and align with the yellow color, the same similar circle of another component. So at that time, those two planes will be intersecting, like they will those two planes will intersect and it will be aligned once. And what type of joint you create will be holding good. This is for normal joint. For assemble joint, always you need to first go to align, and then you need to align first. You will be able to align them wherever in the position you need, and then you will be able to like create a assemble joint for those two components. Just in the assemble joint, you just need to select, once they are aligned, you need to just select the whatever component you need, like those two pair of components, and select the type of joint. This is much simpler. I actually in my person like these two approaches have their own pros and cons. Okay, try using the trial and error, only you can identify which is the best for a particular joint. I hope it's clear, Amal.